In this video you will learn what are the stages of project quality management, what does quality mean in project quality management, how should be a plan for project quality management, what are the tools and techniques for quality management, words of wisdom, life of a project manager, eat, sleep, manage projects, repeat. Project quality management refers to the process of managing and maintaining quality throughout a project. While contextually it could suggest that quality indicates perfection, it is typically more about establishing uniformity of quality across a project in this example. However, what precisely is implied by quality is dependent on what the client or stakeholder requires from the project. Therefore, it varies from project to project. In the modern day, project management and quality management complement each other. They both place a premium on customer satisfaction as well as the underlying premise that quality makes the customer satisfied. The primary goal of quality management is to ensure that the project fulfills the requirements for which it was originally designed, nothing more, nothing less. To put it another way, in order to assure quality, you must fulfill the demands of the stakeholders. Meeting or surpassing requirements, on the other hand, is not a component of project quality management. Quality is defined by a guide to the project management body of knowledge as the extent to which a collection of intrinsic qualities meets requirements. The project manager and project management team are charged with balancing quality and grade. This role guarantees that quality standards are fulfilled. This suggests that although having a decent, low-grade product is conceivable and justifiable, having a low-quality product is never acceptable. The requirements are set at the start of the project with stakeholders. These criteria serve as the basis for the project's work. Following that, the project manager's role is to guarantee that the task is completed without any excess. Quality does not imply providing additional to customers or performing extra labor. Extras are often based on erroneous notions of what you imagine the consumer wants. These add time, potential expenses, and other repercussions to a project, but they do not necessarily result in enhanced client satisfaction. Different stages of project quality management. The three primary stages of project quality management. Quality management planning. A solid quality management plan begins with a clear explanation of the project's aim. What is the product's or deliverables purpose? How does it appear? What is it meant to accomplish? What is the best way to gauge customer satisfaction? How can you know whether a project was successful or not? Answering these and other questions can assist you in identifying and defining quality criteria, enabling you to explore the method and strategies required to attain those objectives. Evaluating the obstacles to success, establishing rigorous standards, recording everything, and developing the techniques and tests to accomplish, control, forecast, and verify success are all part of this process. The project plan should include quality management activities. Assign these responsibilities to work groups and/or persons responsible for reporting and tracking quality. Also, the purpose of project quality management must be adequately communicated to all stakeholders. Quality assurance. Quality assurance is a procedure that provides stakeholders with proof that all activities related to quality are carried out as stated and promised. It ensures that measures have been taken to make sure that all quality output requirements are satisfied. A project's goods and services, including the procedures and processes used to run the project, are subjected to quality assurance. It is possible to do so using mechanisms like a project audit or process checklist. Quality assurance tests employ a metric system to verify the extent to which the quality management strategy is on track. You can successfully monitor project quality and client satisfaction by utilizing qualitative and quantitative measures equally. Such tests will assist you in predicting and verifying target accomplishment and identifying the need for remedial measures. Furthermore, quality assurance audits will assist you in mapping quality measurements to quality targets, enabling you to report on quality status during regular project review discussions. Use the standards and methods outlined in the blueprint to carry out your quality management strategy. Conduct a quality check to see how effectively the team is executing the strategy and fulfilling the expectations of your customers. When standards or objectives are not fulfilled, the required measures and remedial actions should be taken to address the problem. Quality control. Quality control refers to operational measures that are used to guarantee quality standards. This involves finding, assessing, and resolving issues. While quality assurance happens prior to the identification of an issue, quality control occurs after the identification of a problem and recommends means of improvement. Quality control examines individual project outcomes to ensure they meet relevant requirements. Furthermore, it uncovers project risk elements, mitigates them, and seeks strategies to avoid and eliminate poor performance. quality control may also help to keep a project within budget and on time. Testing and peer review may be used to monitor project deliverables. By spotting deliverables that do not match the agreed upon criteria throughout, you will be able to simply change your course instead of having to completely redo particular tasks. This is about monitoring and documenting the outcomes of quality operations in order to evaluate performance and make required improvements. Make sure that the deliverables are proper and devoid of errors, and keep quality in mind from start to finish. Conduct inspections to detect flaws. Begin as soon as possible. Finding and repairing errors close to their source saves both money and time. What does quality mean in project quality management? Quality has a vague definition. It may refer to a variety of things. Take the time, no matter what sort or size of the project you are leading, to outline the quality standards for the current project, enabling your team members to comprehend what it is and how to achieve and improve on it. Understanding the 3 stages of quality management requires a clear notion of quality. To describe quality, you must first understand the definition of the below terms: validation, ensuring that the product fulfills the agreed upon requirements; verification, complying with the requirement; precision, repeated measurements in a small group; accuracy, a measure's proximity to its genuine value; tolerance, the range of acceptable outcomes. If you like this content, please like and subscribe. On my website, projectmanageric.com, you can get the free slide deck templates for your project management needs, as well as training based on my 544-page book Project Management for Managers. Please see the details below in the comments. A decent project quality management plan should have these. While the majority of project managers strive to deliver the greatest product or service possible, even the most competent, educated teams using the most cutting-edge equipment may fail if the proper project quality management strategy is not in place. Assessing quality could seem to be something you can only perform once the project is completed. Nevertheless, project quality management should be built into the project from the start and monitored using the 3 stages of quality management throughout. The planning phase of quality management identifies the quality criteria that apply to the project, as well as devises a strategy to meet them. The purpose is to develop a quality management strategy that includes the following: the manner in which the team will carry out the quality policy, the method through which the projects and products' quality will be ensured throughout the process, resources needed to guarantee quality, the extra tasks required to execute the quality plan, useful quality management tools and techniques. Flowchart. A flowchart is a visual representation of the process phases. As a result, it may explain the phases of any process using graphical symbols linked together by routes that reflect the workflow's direction. The symbols may be circles, rectangles, diamonds, or any other form that must be established in order for the flowchart to be easily understood. The flowchart begins with the start node, typically depicted as a circular shape. Then we use a rectangular shape to symbolize each step or action we take. When we make a choice or do a test that has several outcomes, each outcome will lead us down a different route with a distinct action. When we need to make a change to a process, flowcharts come in handy. It assists us in eliminating duplication and ineffective task stages. It is also quite beneficial while developing the project work statement. Pareto diagram. This is a unique vertical chart separated into categories that displays all conceivable probabilities or occurrences. Each category's frequency is arranged so that the left of the vertical axis features high frequency while the right features low frequency. Pareto is based on the 80/20 rule, which states that 80% of problems are caused by 20% of the causes. So, if we know 20/100th of the reasons and devote more time and resources to avoiding them, it is possible to eliminate 80/100th of the mistakes and issues. So, when combined with the cause and effect diagram, the Pareto diagram is quite beneficial. Cause and effect diagram. It is a fishbone graph that depicts cause and impact. Its head symbolizes the issue or aim, and its body depicts the reasons of the issue or the measures that must be taken to achieve the goal or target at the fishbone's head. When we discover an issue with any process, like process deviation or a growing number of faults, we may utilize the fishbone to determine the root cause. Each resource may also be subdivided into several resources until we reach the problem's initial resources. The fishbone issue statement is often generated by the control chart, as its metrics indicate a problem with process stability. Histogram. It is a technique used to display the central inclination, statistical distribution, and dispersion of a particular set of values on a vertical bar chart. It is quite beneficial for determining the categories that have a higher frequency. It may be used in a variety of applications, including specifying the resources which will do project work using the resource histogram. We can achieve the same thing in a timely way with one resource, such as separating the categories in terms of months and determining the number of one resource, such as a senior developer, for each month of the project's lifetime. Check sheets or tally sheets. This is a sheet which includes inspection and test items as well as the characteristics that each test might result in. The acceptance criteria for each test must be included on the sheet to serve as a reference for deciding if the sample's inspected item, such as a piece of code in a software project, has satisfied a test item. Then we collect each fault's frequency and plot them in a Pareto chart. Scatter diagrams. Scatter diagrams are graphs with two axes, x and y. As a result, each measurement shown in the scatter diagram is depicted by in pair. The x-y correlation depicted is premised on the concept that y is reliant on x while x is not reliant on y. There are several sorts of correlations, such as positive correlation, negative correlation, and no correlation pattern. A favorable connection is a human's weight and its relationship to their age. We discovered that human weight is impacted and dependent on age. As a result, we shall consider age to be the x-axis and weight to be the y-axis. When x is raised, y decreases in a negative correlation. Control chart. A control chart is used to assess whether or not a process is stable. It is made up of USL and LSL derived from specification, UCL and LCL derived from statistical computation plus 3 standard deviation from the mean, mean equivalent to divided by 2. If one point exceeds the UCL or LCL, or if 7 successive points surpass the mean, the process is termed unstable. When we determine that it's an unstable process, we take remedial action and evaluate the outcome to determine the influence on process stability. Matrix diagrams. This one is used to examine data inside the structure of an organization. The matrix diagram depicts the relationships that exist between the rows and columns comprising the complete matrix's goals, factors, and causes. Depending on the amount of items and groupings of things to examine, many kinds of matrices may be used. The many forms of matrix diagrams and each one's applications. L-shaped matrix. This establishes a connection between two objects. T-shaped matrix. This establishes a connection between 3 sets of elements. Y-shaped matrix. This establishes a link between 3 sets of objects. However, it is shown in a circular figure. C-shaped matrix. This one displays a connection between 3 sets of elements. X-shaped matrix. This establishes a connection between 4 element groups. Click on the video card on the right to understand how to create successful project execution. If you like this content, please like and subscribe. On my page projectmanageric.com you can get the free slide deck templates for your project management needs, as well as training based on my 544-page book Project Management for Managers, translated into 8 languages. Please see details below in the comments. If you managed to get that far, I am sure you would love to subscribe to this channel and get free project management templates on projectmanagementic.com website.